integer data types. So integer data are represented by different integer data types. So now first let's discuss integer data types for signed data. The real world data can be, sometimes it may be signed or sometimes it may be unsigned. Let's see some examples. Let's take, for example, temperature value. A temperature can be negative sometimes or it can be positive sometimes. So that's why a temperature value is considered as a signed data, because that data can be positive or negative, right? For example, consider distance between point A to point B. So a distance value cannot be negative, right? So it will always be positive. So that type of data is called as unsigned data. All right, so integer data types for signed data are char, short int, long int, and long int. So all these are different types of integer data types available in C. So remember that instead of calling short int, so you can also call it as just short. So if you just call it as short, then it is assumed that you are referring to short int. So you need not to write or mention long int. So you can just mention it as long. A long is always assumed as long int. And same way, you need not to mention long int. So you can just mention long. And integer data types for unsigned data. So if your data is unsigned, then you can use these integer data types. Everything is same. So what you have to do is you have to use the keyword unsigned before the data type name. So like unsigned char, unsigned short, unsigned int, etc. So you just have to use the word unsigned. So now in the next lecture, let's see storage sizes of different data types and value ranges. I'll see you in the next lecture. 4 bits. So it talks in terms of max and min. So exact size of the long type variable depends on the compiler design. Some compilers fix 32-bit storage size for long type variables, and some compilers fix 64 bits. Same is true for int data type. Some compilers fix 16 bits storage size for int type variables, and some compilers fix 32 bits. So this all depends on the compilers. So these data types will always be fixed size irrespective of the compilers. Short is always 2 bytes, char is always 1 byte, and long is always 8 bytes. So that is guaranteed. Whether you are using cross compiler for embedded systems or non-cross compiler, it doesn't matter. Short is always 2 bytes and char is always 1 byte. So in the next lecture, let's understand integer data type one by one, and let's start with char. And I'll see you in the next lecture. Because its range is from 0 to 255, right? So in this case, we can safely use the unsigned short int data type like below. So unsigned short, so that's the data type, and sun temperature, that's a variable name to hold the value sun's temperature, that is 5505. So that's about variable definition. And in the next lecture, let's see some examples. And after that, we'll discuss other integer data types. And I'll see you in the next lecture. Is equal to, let me store 160 here. So that is my first variable definition and initialization. So here you can see that first variable is defined and after it is initialized. So you can do both the steps in one single line, no problem. So you can do either this or you can do something like this. So you can also do this. So no problem with that. So, but instead of using two lines, you can do it in single line. So here we are assigning the value 160 to the variable distance a to b, which is of type unsigned char. So the compiler, when it compiles this code, it will generate the code to reserve 1 byte in memory for the variable distance a to b. After that, let's create one more variable, unsigned char distance from b to c is equal to 40. Let's create one more variable to store the result, unsigned char, and let me create another variable, distance a to c. So this is a variable to store the result. So how to calculate the result? So distance a to c is equal to distance a to b plus distance b to c, right? Which is very simple. We have to print the value of this variable. Let's use printf for that. So total distance from A to C is equal to, you have to use something called as format specifier. So now you have to inform the printf, how do you want to print the contents of this variable? So do you want to print the contents of this variable as an integer or in the form of hex number or in the form of octal number or in the form of character? So which format you want? So you have to specify that. And we specify that using something called format specifier. So now let's see some of the format specifiers in C. So if you use %d, then printf will understand that you want a result to be printed as an integer format. If you mention %f, and the variable content will be printed in the form of float. So %c for character, %s for string. And if you want to print long int, then you can use %ld like that. If you want hex format, then you can use %x. If you want octal format, then you can use %o like that. So now in this exercise, you can use either %u because you are actually printing unsigned integer, right? You can either use %u or you can use %d. You can also use this because we are printing in the integer format, right? So now let's go back. Let's use %d here. So that's the format specifier we want. So that's a format specifier. So and after that, you have to give the argument for this format specifier. So what you have to do is, this is our message. So our message ends here. So you have to close the message by using a double quote, right? So that you already know. So you can even give /n here to move the cursor to the next line. So this is our message. And you have to give the argument for this format specifier. So that we give after you close the message. So after you close the message, give a comma, and after that, give the argument for this format specifier. And in this case, we want to print the contents of this variable. Let's copy that variable and paste here. That's it. And after that, let's give semicolon here. So that's how you use printf to print the value of a variable. Let's compile and let's see how this goes. And here it is. So we got the output, total distance from A to C is equal to 200 kilometers. Let's make it as 200 kilometers. So now what I do is, after %d, I'll give a space and I write km. You can do that. Let's print. That's great. You can give this format specifier anywhere you want inside the message. So I can even write something like this. For example, I can even write something like this. %d is the total distance from A to C. I can remove this. So that is one format specifier. So there should be only one associated variable. So, or any argument. Let's see how this goes. Let's run. So now it is printing like 200 is the total distance from A to C. Alright, so now if you want to print the content of this variable in the form of hex, then you have to change the format specifier. If you want to print in hex format, then you have to give the format specifier as X, either small x or capital X. So if I use small x, then what happens is you can see that it prints C8. So C8 is a hex equivalent of decimal 200, right? So it actually printed in small letters, right? So if I make it as capital X, then you can see that it will get printed in capital letters like that. So if I want to print in octal format, then I would give O. Right, so let's try. So it doesn't take O actually, capital O it doesn't take, so you have to give small o. Let's try. All right, so 310 is the octal format of 200 decimal. And if you want to print in the form of character, then you can give C, percentage C. And let's run what happens. So this is some unknown character for the value 200. Hey, welcome back to the lecture. So in this lecture, let's discuss about the range calculation of char data type. So we know that a variable of the char data type consumes 1 byte of memory, right? And also we know that the char data type will be used to store 1 byte of signed data. Let's discuss 1 byte signed data representation. Let's see how a signed data will be stored in 1 byte of computer memory. Let's start with 1 byte signed data representation. So 1 byte means 8 bits, isn't it? So out of 8 bits, the most significant bit will be used to represent the sign of the data. If it is 0, then the data is considered as positive. And if the 7th bit or the most significant bit is 1, then the data is considered as negative. And the remaining 7 bits are used to store the magnitude. So magnitude is stored in 2's complement format if data is negative. Signed data means a dedicated 1 bit, that is this bit, is used to encode a sign of the data. So now let's see an example. So now represent the data minus 25 in 1 byte signed data representation. So the data given is minus 25, right? So it has two parts. One is sign and another one is magnitude. So sign is negative and magnitude is 25. Since the data is negative, magnitude will be stored in 2's complement form. So you have to remember that. So out of 8 bits, the 7th bit, that is the most significant bit, will be 1 in this case. And the remaining 7 bits are used to store the magnitude, that is 25, in 2's complement form. Let's see how we can do that. First of all, so the data given is minus 25, right? So now here, let's represent the magnitude, that is 25, in binary format. So let's say 1, 2, 4, 8, 16. So let's write the weightages. So this is 1, 1, and 1. So this is a binary form of 25, right? So in order to represent 25, you at least need 5 bits, right? So, but it is 1 byte representation. So there will be remaining 3 bits. Let's consider them as 0. So this is a representation for 25 or plus 25. So now let's take the ones complement of this binary format. So now it will be 1, 1, 1, 0, 0, 1, 1, 0. So this is a ones complement form, right? Let's take the twos complement form of this. So you have to add 1 to this. So that's how we get twos complement form, right? So this is actually binary. So this is ones complement. What we get is 1, 1, 1, 0, 0, 1, 1, 1, right? So we finally got this number, that is 1, 1, 1, 0, 0, 1, 1, 1. This is actually 1 byte data, right? And observe the 7th bit, that is 1. So this is a sign bit, which represents data is negative. and this is the sign bit, and this is the magnitude. So magnitude for 25 in 2's complement form. So that's what written here. So, and if I convert this into hex form, what happens? So this is the lower nibble and this is the upper nibble, right? And this turns out to be 7, and this turns out to be 8 plus 4, 12 plus 2, 14. 14 means E, right? So this turns out to be 0 cross E7. And so that is actually the hex value of decimal minus 25. So now it is very, very simple. Remember that in signed data representation, a dedicated 1 bit is reserved in order to encode the sign. And you left with only 7 bits to represent the magnitude. Let's move forward. So now represent the data 25, that is plus 25 in 1 byte signed data representation. Here sign is positive, so that's why the most significant bit will be 0. And since the data is positive, you need not to convert the magnitude into 2's complement form. So you just convert that into the binary format here. So this is actually the binary format of 25. And if I convert that into hex, so this will be 9 and this will be 1, right? So that happens to be 0 cross 19, which is a hex value for decimal 25. So I hope you got the idea, and now let's move forward. So now based on that, let's discuss the char data type range. So now let's discuss when the sign is positive. When the sign is positive, the 7th bit will be 0. So the least value what you can store is all zeros, right? So that's why magnitude will be 0. That is the least possible magnitude. And the highest value would be, you can fill all the magnitude bits with 111, right? So that's why the highest positive value would be 127. When the sign is negative, 7th bit will be 1 and 1. The least value possible is minus 128. So minus 128 means all magnitude bits are filled with zeros. So this is actually the 2's complement format for minus 128. And the highest value possible is, that is highest negative value possible is minus 1. So when it is minus 1, all the magnitude bits are filled with 1. So this is actually the 2's complement format for minus 1. So now we have here two ranges for positive values and negative values, right? For positive values, it can go from 0 to 127, right? For negative values, the range would be 0, minus 1, minus 2, all the way up to minus 128. So that's why the range of char data type is minus 128 to 127. So this is a range for char or signed char. Signed char or just char. So now what about unsigned char? So the unsigned char data type is used to store 1 byte of unsigned data. So in unsigned data representation, so no particular bit is dedicatedly used to encode the sign. So that's why we have all the 8 bits to store the magnitude. So there is no sign bit. So that's why the least value would be all zeros, right? And the highest value would be all ones, right? So that is 255. So that's why 0 to 255 is the range for unsigned char data type. And in the next lecture, let's study about short int. I'll see you in the next lecture. Right, so now in this lecture, let's study about integer data type short int and unsigned short int. So variable of type short int is used to store 2 bytes of signed data. Variable of type unsigned short int is used to store 2 bytes of unsigned data. So you can just mention short or unsigned short. So int will be always assumed. Short type variable always consumes 2 bytes of memory irrespective of compilers. So you should remember that. So you go to any compiler, the size of short int will always be 2 bytes. So now let's do the range calculation of short int. Let's take, for example, represent the data minus 25 in 2-byte signed data representation. So here the data is negative, right? So now first let's take the binary representation, that is pure binary representation of 25 in 2-byte data representation. So that will be this one. And after that, take the ones complement. So this is a ones complement format of 25, where you have to convert all ones into zeros and zeros into ones. And after that, let's take twos complement of that. So for that, you have to add 1 to ones complement format. You get twos complement format. So this is the representation for minus 25. So where you can see that the 15th bit, that is the last bit, most significant bit, will be 1 to indicate the data is negative, and the rest of the bits will be used to store the two's complement format of the magnitude, that is 25. So the hex value will be 0 cross FFE7. So that is actually the 2-byte signed data representation of minus 25. Let's move forward. So now represent the data plus 25 in 2-byte signed data representation. So that will be 0 cross 0019 in hex. So I hope you can understand this. Let's see the range. For short, it will be from minus 32,768 to 32,767. And for unsigned short, the range will be 0 to 65, 535. Because for unsigned data representation in 2 bytes, you have all the 16 bits to represent the magnitude. So there is no sign bit. So that's why all 16 bits will be used to store the magnitude. So least value will be 0 and the highest value will be 65, 535. That is nothing but 0 cross FFFF in hex. So in the next lecture, let's understand about int and unsigned int, and I'll see you in the next lecture. Let's explore about another data type, that is long and unsigned long. Long is an integer data type to store signed integer data. A long type variable consumes 4 bytes of memory or 8 bytes of memory. So that is very important. Again, size of long data type is decided by the compiler being used to generate the code for your target hardware. So it is typically 4 or 8 bytes. Welcome back to the lecture. So now in this lecture, let's understand size of operator. Sometimes in programming, it may be required to know the size of a variable. So in that case, we can use the size of operator given in C programming language. So there are many operators which are available in C programming language, like arithmetic operators, logical operators, bitwise operators, etc. So all those things we'll see later as we make a progress in this course. But in this lecture, let's understand operator called size of. The size of operator of C programming language is used to find out the size of a variable. The output of the size of operator may be different on different machines because it is compiler dependent. So in order to understand more about this operator, let's do an exercise. So here I am in the online GDB tool, and here I have created a new project, size of, and I'm in the main.c. So now let's write a small program in order to print the size of char data type. So what I would do is, let me just use the printf statement. So let me write size of char data type is equal to. So now let's use %d here because I want to print integer value. And let me give /n and end the message. Let's give the argument for %d. So now here let's use the size of operator. In order to use size of operator, you have to write the keyword size of. Let's write size of. So this is a standard C programming language keyword, size of. And after that, you have to use the parenthesis. Let's use that. So this is a parenthesis of size of operator. And here inside this parenthesis, you have to mention the operand. So now operand can be a variable name or it can be data type name. So in this case, let's just use the name of the data type. So let's use char. Let's run the program and let's see how it goes. So I forgot to give the semicolon. Let's run. The size of char data type is equal to 1, right? So that is 1 byte. Let's try this same printf with, let's say, short. All right, so now let's run the program. So it is printing as expected. Size of short data type is equal to 2. And now let's try for some more data types. So let me mention here int long, and let's try for long. That's great. Now let's try. And here you can see that size of char is 1, short is 2, int is 4 in this machine. And actually it uses GCC compiler. So the online tool, what you're seeing here, that is online GDB tool, it actually uses a GCC tool in order to generate the code, and it also uses x86 machine to run the code. I mean, they have that kind of server at the backend. And after that, the size of long data type is 8, and size of long data type is also is equal to 8. So we found out that, so for this machine, the size of long is actually 8 bytes and size of int is actually 4 bytes. Here, the operand can be a variable name. For example, let me create a variable. Let's say, let me create a variable of type long. So let's say long, my long history. I initialize this to, let's say, 900. So this is a variable of type long. So you can also mention this variable name as an operand of size of operator. So let me just copy this variable and let me mention here size of my long history. And let me just change this size of, let's say, size of long variable. Let's run. Here you can see that we see the same result. Either you can use the data type name or a variable name. And you can also do this. So here you can see that I'm creating a new variable called size in order to store the value which is returned by the size of operator. So here the value which is being returned from the size of operator, I'm assigning that value or storing that value into another variable called size. And after that, I can also print the value of this variable. For example, here size of, let's say, long variable is equal to %d. So I can just remove this and I can just mention size over here. So like that. So that's also you can do. So I hope you understood about the size of operator. So size of operator is used to find out the size of a variable or a data type. So by using size of operator, you will come to know how many bytes will be consumed by that variable inside the computer memory. So another tedious method to know all these things is to read the compiler user manual. So instead of doing that, you can use the size of operator. So in the next lecture, let's discuss about variables. Hey, welcome back to the lecture. So in this lecture, let's discuss about variables. So variables are identifiers for your data. So data are usually stored inside the computer memory. For example, if you consider this small code here, so here you can see that the 20 and 30, those are actually data. So those data must be stored inside the computer memory to manipulate them, right? So a variable acts as a label to a memory location where the data is stored. So variable names are not stored inside the computer memory, remember, and the compiler replaces them with memory location addresses during data manipulation. Variables are there just for your programming convenience. So it is not actually the part of final machine instructions generated. Variable names will not be stored inside the computer memory. So all those variable names will be replaced by their corresponding addresses when compiler generates the instructions. Let's move forward. So this is how a typical computer memory organization looks like. So here you can see that at the left hand side, you see those are memory location addresses, also called as pointers in C. And these are different memory locations and they are holding different values or data. For example, let's consider this memory location. So this memory location is of width 8 bits, right? So that means this memory location has the capacity to store 1 byte of data, correct? And if you want to store some data into that memory location, or if you want to read the data from that memory location, you have to use its address. And the address of this memory location is 0 cross 0803. So memory location address may be of 32 bits, it may be of 16 bits, it may be of 8 bits. It depends on the computer architecture. So later we can see in our ARM-based microcontrollers, so this memory location address is of 32 bits. So now let's move forward. So let's take an example of a memory location of the computer memory. And let's say its address is 0 cross 0800. And here some value is stored inside the memory location. And the variable name, let's say value A. So this is a variable name. So this is just a name assigned to the memory location address to retrieve the data stored. So variable name just exists for programming convenience for the programmers and doesn't exist post compilation. So only its associated memory location address does. So if a programmer wants to store some data into this memory location, or if he wants to retrieve some data from this memory location, so he just refers to the variable name associated with that memory location. Let's move forward. So defining variables. So before you use a variable, you have to define it first. So this you have seen a couple of times when we wrote some examples, right? So variable definition, sometimes also called as variable declaration. So there is a slight difference between variable definition and a declaration. So let's see later. But sometimes people also use the name variable declaration for variable definition. A variable definition is nothing more than letting the compiler know you will need some memory space for your program data so it can reserve some. Let's move forward. So to define a variable, you only need to state its type followed by a variable name. So if the data type of the variable is char, then compiler reserves 1 byte. If the data type is int, then compiler reserves 4 bytes. So this is the syntax of defining variables. So you just have to state its data type name first, and then you have to write a variable name, so a meaningful variable name. For example, here this is a data type and this is a variable name. So you can see that it carries some meaning, right? So by just looking at it, you can see that this variable is used to store the exam score. Let's move forward. So variable initialization. So here you can see that this is a variable definition and this is a variable initialization where you are assigning some value to the variable. So remember that when compiler generates instructions for these statements, the compiler will be generating instructions to put this value into the memory location referred by this variable name. So, and here observe that variable initialization is followed by first defining the variable. So this is illegal actually. So first initialize, then define. So this is illegal. So when the compiler compiles these statements, it sees that my exam score variable, which is not defined before, getting assigned by a value. So the compiler throws an error here. You can't do this. So variable has to be defined first before you using it for data manipulation. Let's move forward. So this is legal. So variable definition and variable initialization can be done in one single statement. The below statement is legal from the compiler point of view. So you can do this. Let's move forward. So rules for naming a variable. So there are a couple of rules you have to follow. So in order to write a meaningful variable name. So first, make sure that the variable name is not more than 30 characters. Some compilers do have issues with that. A variable name can only contain alphabets. You can use either uppercase or lowercase or combination of them. The variable name also can contain digits and underscore. So only underscore can be used as a special character. So no other special characters are allowed while writing a variable name. So the first letter of the variable cannot be a digit. It should be either an alphabet or underscore. You cannot use C standard reserved keywords as variable names. So these are the C99 reserved keywords. So this table I took from the C99 standard. So in the section 6.4.1, it is mentioned these are the reserved keywords. And these keywords you should not use as a variable name. Let's move forward. So here a couple of examples to see what are legal and illegal variable definitions. First of all, the first one is legal actually because it started with underscore here. So, but it is not a meaningful variable name. So avoid doing all these things. Second one is illegal because it actually started with a digit, right? And the third one is legal, no problem here. And this is also legal because it started with underscore. And this is legal and this is illegal because it started with a special character, right? And only underscore is allowed as a special character. So that's why this is illegal. So this is illegal because here you have special character, that is space, and that is not allowed. And here this is also illegal because it started with a digit. Let's move forward. So what is the difference between variable definition and declaration? So variable is defined when the compiler generates instructions to allocate the storage for the variable. A variable is declared when the compiler is informed that a variable exists along with its type. The compiler does not generate any instructions to allocate the storage for the variable at that point. A variable definition is also a declaration, but not all variable declarations are definition. So let's see an example. Right, so now let me show you the difference between variable declaration and definition. Let me just do a variable definition. Let's say int my exam score. And after that, I assign some value to this variable, let's say 540. So here you should note that this variable is defined in the local space. So this space is called as local because that is local to the main function. So you can also define a variable in the global space. For example, So this is a global space, which is common to all the functions of the program. So this is a global space and this is a local space. So we'll discuss more about global and local. So in the next lecture, maybe when we discuss about scope of a variable. So I can also put this variable definition over here. So this also compiles fine, no problem. And here, this is also called as variable definition in the global space. If I use one keyword called extern, so extern is a standard keyword, is a reserved keyword of C standard. So now, if I try to compile this program, you can see that there is an error. The error is undefined reference made to this variable. So this is called as variable declaration. So here, why it is called as variable declaration? Because when compiler sees this, so it will not allocate any storage for this variable. So here you are telling the compiler by this keyword that this variable is defined somewhere in other file of the project that is outside of this main.c file. So that is the meaning of using extern keyword. So that's why compiler will not allocate any storage for this. So it will assume that it is defined somewhere else in the program. So, but when it tries to generate instructions to put this value into the memory location in the computer memory, so it will have problem because you have not defined that variable. And so that's why finally the compiler says that undefined reference to this variable. So basically compiler is saying that it couldn't able to find the reference to that variable. You said that it is extern, but compiler couldn't able to find that. So that's the difference between variable definition and declaration. So this is a declaration. This is not a definition. And this is a pure definition. And I hope the concepts are clear. And in the next lecture, let's discuss about scope of variables. So in this lecture, let's understand about variable scopes. So variables have scopes. A variable scope refers to the accessibility of a variable in a given program or function. For example, a variable may only be available within a specific function, or it may be available to the entire C program. So depending upon the scope, we have two types of variables. One is local scope variables. So in short, it is also called as local variables. And global scope variables, which are also called as global variables. And let's understand more about variable scopes with some examples. All right, now first let's understand about local scope variables. So here I have a file main.c and I have a function main, and it is actually an empty main function. And let's create a variable inside the main function. So now let me create a variable. So here, this is a variable myscore, which is actually called as a local variable because this variable exists only in this function. So its scope is limited to only this function. So that's why this variable is also called as local scope variable. So now let me create another function. So now let me give the function name as, let's say, my function1. After writing the function name, so you have to give the function body. So you have to give these brackets. So here, this is start of the function body and this is the end of the function body. And also you have to mention the return type. So let's say this function doesn't return anything. So that's why we can mention it as void. And also this function doesn't take any arguments. So that's why let's mention void inside the parenthesis. That's great. So this is actually a function definition. And now let's call this function from main. So this is called as a function call. So this is a function call. So this is a function definition. And after that, so you have to give the prototype of this function. So more on that we'll learn later. So don't worry about that. So you have to copy this function prototype, and you have to mention the prototype or signature of this function definition. So in the global space, and you have to terminate that with a semicolon. So this is a function prototype of function my function one. And now what I'm going to do is I'm going to assign some value to the my score here. So let's say 900. And after that, I'm going to print that. Printf value of the variable my score is equal to %d. And after that, I'm going to run this code and let's see what happens. So it actually printed value of the variable my score is equal to 900. That's great. And after that, what we are doing is we are calling this function, that is my function one. Control comes to here, right? And here I'm going to put something else into this variable. Let's say I want to change this to 800, right? And again, I'm going to print here value of the variable my score, and let me give 002 in order to trace the execution. Let me try to compile. And here it is. So you actually met with an error here that is saying undeclared. So here you can see that the error is at the line 31st, that is right here. So here the compiler is saying that, so this is undeclared or undefined because you are trying to change this variable which is actually local to this function. So its scope is just limited to these brackets. So you cannot access them from some other function. So that's why these variables are called as local variables. You can access them anywhere you want inside this function body, but not outside of that. So what we can do is, in order to solve this issue, if you really want to access this variable from some other function, then what you can do is you have to make this variable as global. So that means move this variable from local scope to the global scope. So I'm going to cut this variable definition and I'm going to put that into the global scope. So now this variable is visible from all the functions of this file main.c. So this variable is now called as global scope variable. So now if you compile the program, so the compilation is fine and we got the output, and here you can see that first we printed this. So that's why it printed 900 here. And after that, the main function is calling my function one. So control comes to here, and here we are going to change that global variable, that is this variable, and its value is now changed to 800. And after that, we are going to print this printf, and so that's why this printf actually printed 800 here. And after that, this function returns here. So we go back to the main function and execute this statement, return 0. All right, so now let's see one more example. So here we have a small code and I want you to predict the output of this program. So here what's happening is we have two variables of the same name. So here you can see that there is a variable called value a in the global space, which is initialized to 4, and another variable of same name, value a, which is defined in the local space. So these statements are absolutely fine because this variable actually lives in local space and this variable actually lives in global space. So compiler has no issues, no conflict of names here. So that's why this program will compile well, no problem. The output of this program will be, let's see, let's run. So the output of the program is 67. So why is that? Remember that, so when the variable names are same between local space and global space, the first preference is always given to the local space. So that's why here value a is referring to this variable definition, so not this. So that's why value a will be 67, because the first preference is given to the local space if the variable names are same. So now this is absolutely illegal. So you cannot define another variable of same name. So this is actually illegal. So it throws error saying conflicting types for value A. Let me remove this. So now let me just modify this code. Let me put brackets here. So I will open a curly bracket here and I will close it here. So I just created a small execution body by using curly brackets. So now what do you think the output will be? So now the output will be 4, not 67. Let's see how. First, let's run the code. So here you can see that value A is equal to 4. So now what's happening here? Let's analyze. Here you can see that this is actually a local variable which is bound to the scope of this area. So this is a small execution body here. So the execution body starts at this bracket and it ends over here. So that's why the scope of this variable is bound to this area. So the moment execution control goes out of this scope, so this variable is no longer valid. So that's why. So the moment control comes to this printf statement, so this is no longer there. So this variable is already died. So that's why there is only one variable left, that is global one, right? So that's why printf is printing the global variable value. So always remember that when the execution control goes out of the scope of a local variable, the local variable dies. That means a variable loses its existence. All right, so here I have another code snippet. So I want you to predict the output of this program. So I will just show you the program. So there is actually int a global variable definition. And after that, so these are the printf statements. So predict the output of this program. So let me predict the output. So first of all, this is a global variable and inside the main, so that global variable is initialized to 25, and then we actually created a small execution body, and this is a local variable which is bound to this scope, and that variable is initialized to 45. So everything is fair, no problem. And the first printf would print 45. That's correct. And this printf would print A, that is 25. So 45, 25. So once the execution control comes to line number 20 here, so please note that this variable dies. So it actually loses its existence. So we are creating one more variable, right? This is perfectly fine and legal, no problem. And after that, here we are adding plus 10 to the value of this variable, right? Here, so let's understand this statement. So here you can see that in order to understand this statement, first you should give attention to the assignment operator. So equal to sign, that is actually an assignment operator in C. And this is called as right-hand side expression. And this is called as left-hand side expression. So first right-hand side expression will be evaluated. So here 10 is added to the value of my var variable. So but what is the initial value of my var variable? So that variable is not initialized, right? So that's why its value will be some garbage value, some random value. You cannot predict that. So some garbage value plus 10, and that value is assigned to this variable. So that's why output of this printf will be unpredictable. So some garbage number will be printed. Let's see how it goes. So let me just compile this code. So here you can see that it is printing 45, 25, and it is printing 10 here. So I think this compilation actually took the initial value of this variable as 0. I don't know why is that. So, but typically this printf will print some garbage value. So let's try once again. So let's do one thing. So let's copy this code and let's go to our Eclipse IDE and let's paste here and let's try in our machine. So let me just compile this code. The code is compiled. So here you can see that this compiler is throwing one warning, that is my var is used uninitialized in this function. The compiler is issuing a warning saying before using this variable, so you didn't initialize it. So that's very, very important warning that compiler issues, and you should pay attention to that. So for this trivial example, that's okay. But warnings like these are very, very dangerous. So now let's execute this code. Let me just go to run as, and let me go to local C and C++ application, and here it is. Here my var is printing some garbage value, isn't it? So that's because this is a local variable and the default value of that variable can't be predictable. In the next lecture, let's understand some more code, and I'll see you in the next lecture. Right, so now in the previous lecture, we discussed about variable scopes. Let's see summary of global variables. So in terms of scope, remember that global variables are visible to all the functions of a program. They are everywhere. Even you can access global variables from another file of the project. After that, default value. All uninitialized global variables will have 0 as default value. And lifetime. So the lifetime of these variables are till the end of the execution of the program. Summary of local variables. So scope would be within the body of the function. Local variables lose existence once the execution control comes out of the function body. Default value is unpredictable, and that what we call as garbage value. And lifetime till the end of the execution of a function in which a variable is defined. So now in the next lecture, let's discuss about C storage classes. I will see you in the next lecture.